welcome to Quadrific. In this video, we are going to analyze the data using violin plots and broad plots of Seaborn library in Python. Before I start coding, let me give you a quick introduction of violin plot. Because violin plots are hybrid of box plot, so I will not go into the detail of box plot. So why violin plots are named as violin? On right side of this image, you can see an example of violin plot, and it is shaped based on a violin. That's why it is named as violin. If we go into its definition, a violin plot is a hybrid of a box plot and a kernel density plot, which shows peaks in the data with respect to its distribution. So looking at this image, we can see that the violin plot is composed of box plot. If you remember that in box plot, this thin line represents 95% confidence interval, center dot line represents the median, and the body of box plot represents interquartile range, which means that 50% of the data reside in this area. But the advantage of using violin plots, we can see a detailed description of data based on the body of violin plot. If you imagine this plot horizontally, and the shape of this violin plot will look like this, and you see that it is similar to a histogram. And in histogram, we can see the frequency of data at every point of scale. So if the body is wider, it means that around this region, data is more frequent than other regions. So that's why in such a scenario where analysis of data distribution based on its peaks is very important, violin plots are useful. So in this video, we are going to generate a similar plot shown in this slide that uses violin plots from Seaborn library. So basically on x-axis, you see a different set of experiments, and on y-axis, you see that the scores are represented that are obtained from each experiment. And you can see that on the same data set, each experiment has different distribution of data. So in this video specifically, we are going to use group violin plots in which each experiment is represented 3 values. So let's start programming. So I am back to my Spyder editor of Python, and you can see that I have already imported important libraries that I'm going to use, one of which is Seaborn that I have imported using alias SNS, and another library I am going to use is pandas because every information about my experiment and its scores are in CSV. I have placed that CSV in my file explorer under the same working directory. I have already opened it in my Microsoft Excel software, where you can see that I have 3 columns named scores, cats, and experiment. Each experiment has different score. So basically this dataset is about having different experiments, and in each experiment I have obtained scores for 3 types of cats. For each cat, I have executed the experiment 10 times. And to print the graph of Seaborn violin plots, I'm going to use experiment column on x-axis, scores on y-axis, and then I will group these 2 columns using the cats column. So basically for every experiment, it will create groups from cats column, and for each cat, it will take a mean over its 10 times executions, and besides the mean, it will also show the total distribution of values. And to generate the violin plots, first I am going to define a user defined function, and this function will take 4 parameters. The first parameter will be the name of file that I will use to save this plot. Second parameter is the name of CSV that contains my experiment details, and the palette is used to change the color through calling the function. And the last 2 parameters are x-axis and y-axis values that will be defined under x underscore call and y underscore call. First, I am going to generate SNS canvas by using reset underscore originate function. Next, I am going to define the font scale as 1.5, and I have used the white grid background of this canvas. Next, I am going to read my CSV using pd.read underscore CSV. That will take the name of CSV including its path. So you can see that my CSV is already in my current working directory, so I'm going to pass only its name. Next, I'm going to call violin plot function of Seaborn object that I have created above, and this plot information will be assigned to variable ax. The first and second parameters of this violin plot function are the x call and y call information that I will receive during the call of this function, and data will be extracted from the CSV file that I have just read above. Next, I am going to define the color palette. Now, because generated information of violin plot is inside ax, I'm going to use this variable to create while limit and define the legend. So in my experiment data, the only minimum and maximum values of score I care about is between -1 to +2. To display the legend, it is important to have a hue parameter inside the violin plot. And if you notice that for now I have not used any hue, so I don't need to print any legend. That's why for now I am going to comment this line. Next, to save this plot, I am going to generate get underscore figure of ax variable and assign it to another variable. And using this variable, I am going to define the size of plot in inches. Here I have used 20 inches of width and 6 inches of height. And finally, using the same variable, I am going to use the savefig function, in which the first parameter is the name of file that I received during the function call, and the format is PNG. Highest resolution that I have used is TBI. It is very important to keep it as it is so that we don't have fonts in blur. Finally, I'm going to call this function, and I have passed all of the 5 parameters, in which the first one of which is the name of file. The next parameter is the name of CSV file. Third parameter is the color palette. Fourth parameter is the column name that I want to use to be printed on x axis, and the last column is the column name that I want to print on y axis of the plot. Now I am going to run this. You can see on this plot the dataset have been printed using the violin plot based on experiment and scores. Based on every experiment that was performed on same dataset, we have different scores. For experiment 3, this is an example of normal distribution where we can tell that most of the dataset is centered around the median of the data. But for experiment 3, we can see that there are certain points where we can see the frequent distribution, but on top we have high peak, which means that here the data is different than other distribution. So this is an example of simple violin plot. Next, I am going to use the group version of violin plot, in which every experiment will be grouped based on the column of cats. So inside the SNS.violin plot, I am going to pass another parameter, which is hue, and the name of column, and the name of column that I want to use to be grouped with x column and y column is cats. I'm going to run this again. You can see that here now every experiment is grouped based on SS, KPL and KPR cats of data distribution. So that's how we can use the grouped version of violin plots. I forgot to change the name. I should use it violin plot. Let me run again. Now you see in my file explorer that the violin plot is saved in the format of PNG. And if I open this, you will see that the font is in perfect resolution without blurry effect. Using the same library Seaborn, we can also generate the box plot. Keeping the lines same, we are going to only replace the violin plot with box plot, and you can see that we have plots in box. And in my files explorer, I can verify that the box plot in the format of PNG is also saved correctly. I can see that the fonts are in perfect resolution without blurry effect. So that's how you can generate the box plots using the same library of Seaborn. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.